This is only like my third or fourth time out here in Grand Rapids, and I gotta say, every time I come out here, it's an amazing city, and I'm jealous of all of you. So thanks for coming to see me talk tonight. I'm gonna talk about blockchain and Ethereum, and before I do that, just a little bit about myself. So totally biased, I love Ethereum, really big nerd. I got into Bitcoin in like 2013. I discovered Ethereum in 2014 and 2015. And so yeah, love Ethereum. I'm an entrepreneur. I have a background in open source software. I built a web development shop in Michigan called Commercial Progression. I sold that last year to a company based out of Chicago. And my background's in computer engineering, so still nerdy, even though I went down the business route. And just small disclaimer, I hold investments in Ethereum and Bitcoin and related projects, so take everything I say with a grain of salt and go validate it yourself. So we're gonna speak tonight, three main areas. Number one, what's a blockchain? We'll talk about something that maybe resembles Bitcoin, not specifically Bitcoin, but what is, maybe you hear about blockchain or blockchains, kind of what is that data structure in general. We'll talk about Ethereum, and we'll talk about where Ethereum's going. So really quick, show of hands, how many people here have ever heard of blockchain? All right, good, so about 75, 80%. And then of you that raised your hands, how many of you have heard of Ethereum? Okay, so about 25, 30%, cool. I will try to explain this stuff in a way that makes sense. Very complex topic. I think we'll have plenty of time for Q&A. Sometimes we can kind of go into a tangent and get totally derailed. So for the sake of everyone's time here, if you've got a really complex question, or if we kind of get into the weeds, I'll kind of ask you to save it till later. And I'd be happy to talk to you after the meetup over dinner or beer or whatever. Certainly if you have any shorter questions or you think it might help the audience, by all means, stop me at any time and ask. So with that, we'll dive into the first part of the presentation, a brief overview of, again, a fairly complex topic. Some portions of the topic have been simplified, so instead of going deeply into describing what is public key encryption and what are the specific hashing algorithms that Ethereum uses, I probably won't go that deep. I may simplify it, such as you solve a really hard math problem. So part of that's just I don't know, and part of it is I'm trying to simplify it. So hopefully you don't call me out on that too much. And so, yeah, why do we care about blockchains? Blockchains allow trustless transactions without a third-party intermediary, and that sounds kind of maybe precise, maybe kind of simple, maybe it doesn't make any sense. Think about it this way, though. It's actually unprecedented in the history of mankind. If you ever wanted to trade something of value, you needed to rely on number one, either trusting or knowing the person you're doing business with. Hopefully they're not pirates on the high seas or someone that's going to rob you. Otherwise, you need to depend on a third party to vouch for both parties in the transaction. So that could be it could be a government saying this is legal tender. It could be a bank saying we're going to honor the transaction and clear it and handle that check for you. It could be your buddy Bob or something. So it wasn't until something called blockchain was invented that it provided any sort of method to have trustless transactions between people or you'll hear me use the word peers that don't know each other, that are total strangers. And so if that doesn't make sense, hopefully by the end of tonight it'll make a little bit more sense. But we'll kind of move forward and talk a little bit about what a blockchain is. And maybe before I go into that, any questions right off, like short or small questions right off the bat? Maybe something you've wondered about blockchain for a long time or anything? One there.
Is it possible, if it's a ledger, is it possible for some third party that we don't really need, but malicious to insert a transaction from the outside without anyone knowing, just suddenly it's there?
Right, great question. And the short answer is maybe. Right, and it definitely depends on the specific blockchain protocol. So helpful to get that question. We'll dive in a little bit more, and then we'll touch upon that at some point. So we'll start from really high level what a blockchain is. It's two things. It's a distributed ledger, and it's a consensus. So if you get lost in the weeds or confused at any point when I'm talking tonight, remember those are the two ingredients that create blockchain. And we're going to go through these two ingredients in the coming slides to kind of break that down. But if you kind of always go back to that distributed ledger and consensus about that ledger and what it contains, that's really what a blockchain is. And for the video presentation, we'll have slides edited in. I understand. So there's a kind of like a formal definition I put up. You don't have to worry about reading it right now. We're going to go through all that stuff right now in the following slides. So let's start with the transaction. All right, you've got account A and account B, and let's say we want to send 10 tokens. This image here kind of represents that. We've got two accounts, 10 tokens. It could be $10. Tokens just kind of a placeholder. It could be 10 units or whatever you want. It could be 10 cents. It could be 10 Bitcoin. Oh, sorry. This is kind of where I'm simplifying it. So typically when you want to issue a transaction, this is where you would need private keys and public keys to sign that transaction and validate it. So we're not going to get too deep into that. But if you were to study more, then you would start, that's kind of where you'd start encountering, what is that transaction? How do you actually issue a transaction? For tonight's talk, just think about it as, it could be $10, it could be whatever. It's a transaction in the natural sense of a transaction. And so we want to take transactions and build a ledger. So you could think about a ledger, if any of you have ever done consulting or run a business, maybe you've used QuickBooks or some sort of accounting software, maybe FreshBooks or something. Maybe some of you have used something called Excel. You could think of a ledger as kind of rows and columns. So you've got rows of different transactions, and each column could be different accounts. So the point is you've got things moving from account A to account B. And in our example earlier, we're moving 10 tokens. Those transactions are compiled into blocks. It's an indeterminate number of transactions. So you could have 100 transactions in a block. You could have 1,000. You could have no transactions in a block. The point is, at some point in time, in Bitcoin's case, it'd be every 10 minutes, transactions are collected and added to a block. Does that make sense? Any questions about that? Any questions about what a ledger is? Yeah.
So in your Bitcoin example, is that all transactions globally every 10 minutes are put into the same block, or is there some just on one node?
Great question. So we're going to talk about consensus and peers in a few minutes, but I'll kind of precede that with there's a global pool of transactions waiting to be added to a block. So if you think about it like just like a message is broadcast, so then there's peers or people or computers sitting out there listening for those messages, collecting them in a pool or a queue, and then when they decide to create a block, those specific peers, or you may have heard the term miners, are choosing which transactions they want to include or not include. And we'll get into maybe why they might include some and not others in a few minutes. Any other questions so far? Nope. Yeah.
You might talk about this later, but is there there's a length limit or some kind of way to decide when we're done with the block? Maybe that's too complicated.
Yeah, we can definitely talk about that later. There's a lot of debate in the Bitcoin community specifically about those limits. We'll definitely wait till later to talk about that. So So we talked a little bit about a ledger is just a list of transactions. For the sake of a blockchain, we need to break those transactions up into blocks. We can't have a blockchain without blocks. So again, you can think about it like in Excel again. If you were to maybe print an entire ledger or spreadsheet out on a bunch of pages of paper, you could think about each 8.5, 11 page of paper, it's going to cut that Excel sheet off and continue on to page 2, page 3. You can think about each of those pages like a block. Oh, one quick note too. I happen to have like some block numbers here, like block 100, block 99, 98. I'm just trying to show that there's numerical order to those blocks. The numbers aren't significant. All right, so we've got transactions. We've got those transactions which are combined into blocks, and it's called a blockchain because every new block points to the previous block that was on the chain. So in this example, we're creating block 100. It has to refer to what the last block was, which was 99. Block 99 points to 98, and so forth, all the way back to the very first block in the chain. That's typically called the Genesis block, and that's the case in Bitcoin, Ethereum, and other blockchain protocols out there. Yeah, so we talked a little bit about the time interval. So blockchains could create a new block every second if you wanted, or every 10 minutes, or every hour. The nature of blockchain is the specific protocol or blockchain you're working with, that implementation could have different rules for when you try to create those blocks. The reality is, though, that that's just a kind of a moving average target. The nature in which you create these blocks, typically like in Bitcoin or Ethereum, you could aim for a 10-minute block time, and you could solve a block after 2 minutes, after 2 seconds, or maybe after 30 minutes too. So again, the protocols, and we're going to talk about consensus and consensus protocols briefly. Those protocols are written to kind of evaluate that block creation time over a period of time. It could be 2 weeks or 2 hours, and then adjust the difficulty of that really hard math problem, which we're going to get into really quick. I may have jumped ahead. Sorry if I confused anyone. Yeah.
Pretty similar question. Does Bitcoin have one ledger or many ledgers?
So yeah, when you hear people talk about Bitcoin, they're talking about a single public blockchain.
Single ledger.
Yeah, single ledger. All right. So if we go back to the two ingredients of blockchain, we talked about a distributed ledger and consensus. So we just talked about what a ledger is. Now we got to distribute it, right? So if you're familiar with like BitTorrent, you've got data sitting out there distributed, or maybe some of you guys have used like AWS and you have like mirrored servers and stuff. The idea is we've got a ledger that could be a file or a collection of files, and it's copied among different computers or nodes. They don't necessarily have to be PCs or servers, or maybe they could even be a mobile device, but we got to distribute it. And so the question about Bitcoin was really good. So yeah, there is one ledger. I don't even know how big it is. It's gigabytes and gigabytes now, and copies of that sit on peers around the world. And so we've got distributed ledger, and that's the first ingredient. And I know I may be pausing a lot, but any questions so far?
So Dogecoin would have a whole other ledger and a whole other set of peers.
Yes, exactly. Cool. Okay, so kind of leading into the next step is, so we have all these copies of the ledger or the blockchain out there. We're collecting transactions. Now we have to add those transactions to a block and append it to the chain. So how do we do that? There's no centralized authority. There's no central server in most cases, at least in the truest sense of a blockchain. So at some point, one of these peers says, hey, I've gotten the next block. You don't say, trust me. We need a better way because we don't want to trust that. That could be, I think there's a question about how could there be incorrect transactions or false transactions added. Like, we don't want to have to trust the transactions that this peers adding. So how do we do that? How do we come to agreement as separate peers with separate copies of the blockchain? How do we come to agreement or consensus as to what the next block is? So that's what we're going to talk about next. So consensus. Anyone here know the definition of the word consensus, or maybe like a rough definition? What's that?
Broad agreement.
Broad agreement, yeah. And what do we agree on? Anything? I gave this talk a few months ago, and people defined it as everyone agrees. And then someone else said, no, that's not right, out of the back of the room. And it was that everyone agrees to the result. So you may not agree, for example, if you were to vote for, I mean, a really popular consensus mechanism we have in this country is like we vote for president. And I spoke about this in January, much hotter topic back then. Everyone forgot about it by now. But it's kind of interesting, right? So not everyone agrees who the next president should be. Everyone has their own votes. But our consensus mechanism is, as a country, is we agree to the results, usually. All right, that's all I'm going to say about politics. So there are different, yeah, it's not political, right?
Do you distinguish it from unanimity?
That would depend on the specific consensus protocol. So we could, all right, so going back to elections, not politics, but going back to elections, there are some countries that may say if you don't have what is a supermajority, like over maybe 50%, there's a runoff election where you have to redo the election. Other countries like ours say, well, you could have 44% between, what, 3 candidates, and 44%, as long as it's more than anyone else, is good enough to move forward. So it depends on the specific rules of the consensus protocol you're using. And so one of the ones we're going to talk about is called proof of work. And this was one that was originated by Bitcoin. There are other very interesting consensus protocols out there. There's a cryptocurrency or blockchain called Ripple, which I believe uses a totally different type of consensus protocol. It actually has like it has some trusted peers that kind of coordinate that. I'm not an expert on Ripple, so I won't talk anything about that protocol. But proof of work is the consensus protocol that was invented by Bitcoin. And so we'll dive into that a little bit, and then a little bit later we'll talk about another protocol called proof of stake. Okay, so I alluded to earlier, I was going to talk about hard math problems, and I mentioned the word miners, and I've used the word peers. About 75–80% of you said you had heard of blockchains before. How many of you, by a show of hands, have heard of something called miners or mining? Okay, yeah, so about half of you. Yeah, there's a lot of discussion around, is mining the best way or the right way to come to consensus? And we'll hold off on discussing that just yet. I think there probably is a case for and against it, and we might touch on that a little bit. But let me kind of talk a little bit about this really hard math problem, what it is and why it's needed to come to consensus, and why it was such a cool invention by someone or some group called Satoshi Nakamoto, which is totally anonymous, but pretty revolutionary. And so I like to compare it to if you didn't have proof of work, if you just had some sort of rule that said whoever came up with the next block fastest, then you could have someone that's on the fast internet connection in like a data center, and they could have more influence over the guy just sitting. I read an article in Hawaii how gamers can't compete on these big game tournaments because there's too much latency and lag from the Hawaiian internet connection. They were complaining about that. Anyway, we want to make sure the people in Hawaii have as much of a chance to create the next block as the big company running the data center, right? So proof of work is this idea that you actually have to do work and prove that you did that work in order to create the next block. And we need to make sure that everyone can't do the work at the same time, because then we have the issue of that everyone could create that next block or propose that next block. And so proof of work is essentially a really hard math problem where you take all the transactions you want to add to a block, you create that block, you add in some data from the previous block. So any of you that are familiar with computer science, maybe you've heard of linked lists or pointers. The fact is you've got a reference in this new block you're creating to a previous block that's already accepted by the rest of the world, and it's copied on this ledger that's all over the place. But this new block we're creating has a reference to the previous block. It has the transactions we're including. You take all that data, you perform a math function on it called a hash. So you take all that data and you convert it down into a string of numbers. In the case of Bitcoin, it could be like 256 bytes or bits. I don't know the number for Bitcoin specifically off the top of my head, but the point is you end up with a single number, and then you take that number and you have to run it through a specific proof of work function. And the way I would compare it to is that anyone here, I guess people still use zip files, right? So you can password protect zip files. And if you're like me, maybe you've been a nerd for a long time, so you've got zip files from like the early or mid 90s where maybe you set a password and you can't remember what it was. I don't know. Maybe some of you identify, maybe you don't. but hey, security is important. So if you forget the password to the zip file, you could start at 1 and then 2, and then you could essentially brute force try to guess what your password is by starting at 0 and working your way up. If the password you created was, say, only 4 characters, there's not too many combinations to guess it. Eventually, even if you're a slow typer, you're going to figure out what that password was because it was only a 4-character password. If it were 7, yeah, manually that'd take a long time, so maybe you have a computer program do it for you. 7, with today's technology, you could solve really quickly. As you add 8, it exponentially increases in difficulty. So if that was, say, a 12-character password, like the combinations of passwords it could be, if it's all letters and numbers and special characters, like there's probably fewer stars in the galaxy or maybe the universe as far as how many combinations there could be to that password. So the point of that comparison is you can have a brute force math problem that is really easy, like the 4-character password, or very hard, like the 12-character password. And so the way in which proof of work adjusts its difficulty is by changing, essentially kind of changing the length of that password. And this is where I'm kind of dumbing it down a little bit. Not because you guys can't handle it, but because I don't know it fully. So if you think about it that way, though, so say in this case we had 5 peers or 5 computers or 5 miners trying to guess what that password is and inputting this hash from this block and these transactions, it's going to take them a little while to do that work. And when they do solve it, it's likely only going to be one of them at a time. And then they can say, hey, listen, I have the answer to this hard problem. Here's the proof. You can check it very easily. And again, I won't go into the math of that, but the fact is if you were going to brute force something, cracking a password, it takes a lot of work to go one direction to figure it out, but to verify it's very quickly. You could essentially, as another peer in the network, say, okay, this is the password, this is the zip file or the really difficult math problem. I can verify it very quickly, so I don't have to go through the same work that it took to create that answer. Any question back there?
Yeah, so is that why before you used to be able to mine for Bitcoin with a single core processor, now you have to have a dedicated ASIC miner to keep doing these calculations to get anywhere?
Exactly, yeah. So in the case of Bitcoin, like you mentioned, the amount of processing power around the globe going into solving for that next block is so immense that the difficulty's just gone through the roof. So it used to be maybe 5 or 6 years ago, maybe 7 years ago, you could use just an average computer with a CPU. Then it moved to using specialized GPUs to do more calculations faster. And then it moved to ASICs or specially designed chips to run those hashing functions even quicker. And then it got to the point where instead of people creating those ASIC chips and selling them, they just kept them to themselves and just mined their own Bitcoin. So yeah, does that answer your question?
So each of these miners, they're not writing software to do these problems. The package to solve these problems is you can deploy. This isn't. Right?
That's a great question. So in the case of Bitcoin, the protocol is defined by a specific implementation, the Bitcoin client. And I am pretty sure there are miners out there that have written their own custom software. I read recently, maybe a couple weeks ago, there is a potential flaw is probably too strong a word, but there's an edge case where if you change the way that you mine your Bitcoin blocks, you can essentially kind of solve 10% of the time faster or something like that. So I believe there are miners out there that have written their own software to do it quicker.
But the majority of the peers, there's a I don't know, maybe it's not the term, but there's a consensus of this is the software
Yeah.
you should use to take part in the
Yep.
blockchain process.
Yep. Any other questions? Yeah.
How does one become a node in this process? Like, is it just anybody that does a transaction?
Great question. Yeah. So I've kind of used the terms nodes and peers and miners, and I kind of use them interchangeably. The reality is there are different types of nodes. You could have something called a full node where you have the entire copy of the blockchain, and in this case, talking about Bitcoin, that could be gigs and gigs and gigs. I honestly don't even know how big the Bitcoin blockchain is. I know in 2013 it was like 5 or 6 gigs, and it's probably way more than that now. But you could have someone that has maybe a Bitcoin wallet, so they don't have the full blockchain. They have what's called like a light client, and so they may just need to be able to announce transactions to the network, but they aren't actively trying to solve for blocks or anything like that. So does that answer that? Cool. Any other questions?
And the reward, when you solve the block, if you're lucky.
Yes, good. That's where we're going. Yeah. Why do we want to solve the block? Good question. All right. We'll get to that right now. So yeah, why do people mine? Why are they trying to find the next block? Well, a couple reasons. One, there's in Bitcoin, there's a reward of 12.5 Bitcoin for every block. So that means on average, every 10 minutes, a new block's created. And 12.5 Bitcoin goes to the miner that creates that block, where there's consensus on the Bitcoin network that is the next block. Bitcoin, I think today hit about $1,250. So that's a considerable reward every 10 minutes going to some lucky miner. Additionally, if you're a Bitcoin miner, all the transactions you include in your blocks may have transaction fees associated with them. So you may look at the pool of transactions, maybe there's 100 transactions and maybe 10 of those don't have a transaction fee. As a miner, you may choose not to include those in your block. So if you issue a Bitcoin transaction on the network and you don't include a transaction fee, you may be waiting around a long time for some altruistic miner to come around and say, hey, let's just throw that transaction into the next block because, and those fees could add up, especially, we'll pivot a little bit right now. Someone brought up how much can you fit in a block or how many transactions. And so yeah, one of the issues in the Bitcoin community right now is there is a 1 megabyte block size limits. So in Bitcoin, the amount of space a transaction takes, I'm trying to remember how it's determined, but I think it's determined by you can have multiple inputs. So you could have Bitcoin in, say, 3 different accounts, and you could combine those all into a transaction that then outputs to another account. Depending on how many inputs and outputs you have, I think it changes the size of your transaction. And so you could have a transaction worth 1,000 Bitcoin and a transaction worth 1 Bitcoin, and they could be totally different sizes when they're actually included in the block. So yeah, the 1 megabyte limit is kind of tough because Bitcoin is popular enough and there's enough transactions now to where it's not unusual sometimes for transactions to go hours, maybe even sometimes days when they've included a transaction fee, but no miner is willing to include them in a block, and that kind of sucks in a way. Other people say it's not a problem. You know, if you're a miner, you want to drive fees up maybe, and so maybe you don't see it as a problem. It's been a pretty big debate in the Bitcoin community the last 3 years, and I personally think it's probably holding Bitcoin back, but I'm not a huge Bitcoiner, so I don't know. Don't listen to me. But moving on to cooler things, Ethereum gives you 5 Ether every block that's created, and something called gas fees. And we'll talk about what gas fees are. You could think about them like transaction fees in a way that transactions have fees associated with them to encourage miners to include them. And Ethereum has an approximate block time of every 15 seconds, which it was 14.7. I think it's a little over 15 seconds right now. And it's actually going to go up a little bit more in the coming couple months. And then hopefully go down maybe as low as 3 or 4 seconds. But for now, we'll talk about gas fees later, but think about them just as transaction fees.
Who pays those fees?
I'm sorry?
Who pays those fees? Who funds this?
Right, so if you go back to maybe the 3rd slide where we had the example of the transaction, whoever is trying to do that transaction wants that transaction included on the network, they're paying the fee. So if I want to send you a Bitcoin, for me to issue that transaction on the network, I'm attaching a fee so that it gets to you.
And that's like in the transaction when they make it, it says like, here's my transaction and here's the fee I'm willing to pay for the transaction.
Yep, exactly.
And then I'd have to like have an, like I can't input a transaction for somebody else's account. There's some mechanism to prevent me from, like I have to know what my account is and nobody else can have a.
Yep. Yeah, so that's a great point, and I'll dive into that a little bit more. So earlier I mentioned something about encryption and private and public keys. For you to issue a transaction, you have to have a way to prove that you're allowed to do that transaction, and you say own an account in this example. The way you would do that is something called public key encryption. So there's two keys, a public key and a private key that you have. And so the public key is used by people to verify the authenticity of a transaction. So I may not know how to generate that transaction with that account, but using the public key, I can verify that it is a legitimate transaction to that account because it was signed with a private key. And it gets into really long prime numbers and really kind of deep cryptography. And it's probably beyond the scope of this presentation today to explain how that works. Good question. Any others? Yeah?
How do you know there's consensus on a block or when that's been decided? Because like 2 miners can come up with a block at the same time.
Mm-hmm.
You have to fight for it, but you don't necessarily know. Like theoretically, can like someone create like a different chain and then later down the line say like actually this one's better and then have everybody switch to it?
Right. Yeah. And so depending on what blockchain or consensus protocol you're using, the rules for like those race conditions could be different. I probably know Ethereum better, but I'll give a shot to Bitcoin since we've been talking about it a lot in this section. If you had 2 miners create a block at the same time, I'm trying to think if I know the rule for it. I think there's a nonce or some other factor where you look at what's the lower number, and that's the one that would win out. And I apologize, I could be totally wrong. I'm not an expert on the Bitcoin consensus protocol specifically, but I know that in Ethereum there's probably 3 or 4 conditions that look at what's the longest chain and what block gets included. So that's something where I could probably look that up and give you an answer really quickly after the presentation. But that's an excellent question. And maybe a little bit deeper on that, in Ethereum, and maybe Bitcoin too, you could conceivably have people receive a block and then receive another block, and then say maybe you get 3 blocks deep, and then find out, well, no, actually, it's this other block, and you actually have to reorganize the chain. And in Ethereum, that actually happens pretty frequently sometimes. And so in Bitcoin, if that that chain changes after the fact, it means all the transactions that were written in those 3 blocks that essentially got erased, they're basically nullified or reversed. And so the danger is, well, what if, I paid him in, we'll call it block 1, and then in block 3, he's already downloaded the free, or not the free, but the expensive ebook I sold him. Now he's got the ebook, the transaction got reversed, so I don't have the money, so what do we do about that? And what you'll find is a lot of times people, in Bitcoin specifically, would recommend you wait until that transaction is essentially 6 blocks back. So you've got what's called 6 confirmations, or 6 blocks deep, where the likelihood of that chain reorganizing and those transactions being changed is statistically a lot less likely. And in Ethereum, it's pretty much the same way, except those blocks that don't get accepted or get lost, the miners that found them actually do get a reward. It's called an uncle reward. And I think it's about 3.5 Ether. In Bitcoin, those miners don't get anything. So great question.
It's the 6 blocks deep, so that's literally an hour.
In Bitcoin, it could be an hour. There's been times where blocks take a lot longer than 10 minutes, so it could be a couple hours, it could be a couple days maybe, I don't know. I mean,
Essentially, you never know for sure then, you just have, it's just statistically far less likely it's not going to.
yeah. Yeah, in the case of Ethereum, since blocks are created approximately every 15 seconds, waiting 6 confirmations, probably just be a couple minutes.
I mean, mostly that's covered just by how much of the change has been absorbed by the rest of the participants. Like that's what the it's like, because even if you let's say you had
No, it's all right. If it comes back to you, definitely bring it up again, because it's complex stuff, no doubt. All right, let's we'll move on. We'll finish up blockchains and move into Ethereum here in a second. But just a brief history. So Bitcoin was like the idea of Bitcoin and the protocol was kind of documented and released to the world on Halloween in 2008 by someone calling him or herself Satoshi Nakamoto. No one knows who Satoshi is, or Satoshi. Kind of interesting. And then 2009, the client was released. It's open source software. So people around the world, besides Satoshi Nakamoto, were able to work on this. And some of those people are still involved today. 2011, because Bitcoin was open source software and is open source, someone's like, well, why don't I just create something called Litecoin? It's basically Bitcoin, except I changed the name in the code, and I released it. And it took a long time for someone to do that, but like Litecoin's still around. And I think it hit $50 once, and I think I heard last week like it was kind of getting pumped up. So Litecoin, I don't know a whole lot about it other than Bitcoin's kind of stuck in this conversation over the last few years about block size debate and something called SegWit and Bitcoin Unlimited, that I think Litecoin actually is approving these features that Bitcoin's trying to approve. So I don't know. I mean, maybe Litecoin could replace Bitcoin. Maybe not. I don't know. It's kind of weird. And of course, Litecoin was just the first thing kind of called an altcoin. And today, there's probably like 900 different altcoins out there. So a lot of clones. Some are very unique and have different takes and ways about how they may come to consensus or track things on the ledger. And then in 2014, there was an Ethereum white paper released. And so there's this like 19-year-old kid goes down to the Miami Bitcoin conference and talks about this idea for this general purpose blockchain he had. And his name is Vitalik Buterin. I don't know if I pronounced that right. But yeah, so later that year, Ethereum raised like something like $17 or $18 million. They actually sold Ether before the client or protocol even existed. And so essentially, they created something where you could at least create an account with a private key and something called a pre-sale wallet. You sent your Bitcoin to the Ethereum Foundation. and then you trusted that eventually they were going to come out with this weird blockchain that no one really understood, and you were going to have some Ether. So like, I kind of remember when it was announced, and I'm like, I don't even get Bitcoin at this point. Like, I don't even know what to think about Ethereum or these other things. And so I unfortunately did not participate in that crowd sale. But it was record-breaking, and still, I think, in maybe the top 10 largest crowd sales that have happened. And so, yeah, come 2015, I think it was like into July, right before August, Ethereum came out of alpha phase and kind of went into beta with Frontier. And so it was real, and people could take their pre-sale wallets and claim their Ether. And I think it was sitting somewhere like around $1 or $2 for one Ether back then. So yeah, just a quick brief history. Next, I'm going to go into Ethereum. So any questions, I guess, about blockchains in general or Bitcoin or anything that we've covered so far? Yeah.
When you mentioned the fork between the two big Bitcoin things there, with those, when something like that forks, broadly speaking, does that mean two separate ledgers at that point on, or is it literally like one part of the chain goes here, one part goes there, and they go back to a common ancestor, like a tree or something?
Great question. So I don't know if I specifically used the word fork in that context. If I did, I used it incorrectly. Really what we were talking about was we'll call it chain reorganization. A fork.
You said the SegWit thing or the...
Oh, SegWit. Yeah, okay, yeah. So yeah, forks, we'll talk about forks a little bit later.
That's fine.
But yeah, great question. And I very well could have misspoke. Any others? Yeah.
Probably misunderstanding this, but just for clarity, it appears that the mining thing becomes more and more difficult as this thing gets older.
Yeah.
So why doesn't it just hit a wall?
Oh, that's a good question. If it got too hard and blocks weren't being mined, the protocol would, again, self-adjust to lower the difficulty so that blocks are being found again. Does that make sense? Yeah. Yep. Any other questions? That's a great question.
Sorry, one more question.
Yeah, no problem.
Kind of bugged me. You said the computation for the next block involved a hash of the previous block, and blocks are added every 10 minutes. So does the entire transaction computation have to be done in the next 10 minutes in order for that next block to be added? Is there that time limit?
That's a great question. Yeah. So.
If it's so computationally complex, how would you get it done?
Right. So if you brute force starting at 0 and moving up every time, I guess sometimes the answer might be 1, right? So there's times where you could find it really quick. And there are instances where you can watch the Bitcoin blockchain, you'll see a block happen that you've been waiting 30 minutes for, and then 10 seconds later, the second block's created, and you're like, well, what the hell? But yeah, so sometimes it can happen really fast, sometimes it can happen much slower, no matter what the difficulty is. Does that make sense?
I think all of those questions were around one thing. The complexity is tunable, right?
Yeah,
Okay.
exactly.
It's not inherent, it's we can make it as complex or as easy as.
Exactly, yep. Cool, all right, well let's, oh.
Basically, too many people are wasting cycles, not being the one that actually gets the next block benefit.
Yeah, so it's interesting, you could have some attrition, right? It's like, you know, if any of you have ever tried to fire up your own blockchain miner, you know, for whatever, Ethereum or Bitcoin or whatever, like if you were to go home tonight and create your Bitcoin miner, you know, you'd be waiting a long time till you found that next block in all likelihood. So you'd probably just turn it off, right? So in a way, the network hashing power is going to go up, you know, for a second while you've got your miner running, and then it's going to go down, right? So you could get people that get discouraged. You could have a new ASIC or product hit the market, or is starting to be used by a group of miners out there that now are cutting into your profits as a miner. So now maybe the miners you bought last year aren't that profitable, so you go away. So difficulty could go up or down. the goal of the protocol is to keep that block time every 10 minutes. Yep, back there.
Is there any way to tell how many miners are out there actively mining at any time?
I guess you can get an idea by seeing who creates blocks, and then also I think one thing I didn't talk about is, so if you have a smaller miner, what you could do is essentially combine your power with other miners. You could pool it with other miners, and these pools exist and power a lot of the hashing power out there. So the pools probably have a good take on how many miners are out there in their pool. But I don't know if there's a good solid source that tells you that or not. Yep.
So the most successful miners are the ones with the best hardware.
Probably. Yeah. Or are really smart and know about some zero-day exploit that they're not telling you. All right, let's move on. These are great questions. I love the questions. Keep them coming. Let's talk about cooler stuff like Ethereum, though. So yeah, we're going to talk a little bit more about a specific public blockchain called Ethereum, which I am absolutely biased on. I think Ethereum's cool. I spent a lot more time with Ethereum than Bitcoin, and so let's talk about that. Okay, so what is Ethereum? In short, it's a Turing-complete blockchain. I'll preface the description of Ethereum with a couple more facts. You could think about Ethereum and Bitcoin as being complementary. They don't necessarily have to, one doesn't have to win out. It doesn't have to be Ethereum versus Bitcoin. Some people have compared it to Bitcoin's gold and Ethereum or Litecoin or something. Some other altcoin could be silver, right? I mean, they both have value and utility. And then another thing I would say, and I guess not really meant as a dig, but think about Bitcoin like a dedicated purpose device, like a calculator. A calculator does computations. It has a single purpose. You could think about Ethereum like a Turing machine or a general purpose computing device. A computer, it's like your cell phone. It can do calculations. It has a calculator on it. It also does fun things with mobile apps, and you can even talk on it. So think about the two like that. So I'll kind of run through some of these slides a little quicker, but just to kind of compare and contrast, like Bitcoin, Ethereum is a public blockchain. No one person or company or government controls it. It also uses a proof of work consensus mechanism. So there are Ethereum miners out there finding the next block approximately every 15 seconds. And then something else, oh, I'm sorry, really quick. Yeah, so on proof of work, one difference between the Ethereum protocol and Bitcoin's protocol is in Bitcoin, the actual implementation of the Bitcoin client is the definition for the protocol. So you have to read the code to know what the definition is. In the world of Ethereum, between white papers and yellow papers, and I think there's a mauve paper too. There's all sorts of different papers, but there's actual definitions and documentation defining what the protocol is. And then from the start, Ethereum aimed to have multiple major clients. So Ethereum launched Frontier in 2015 with I think 4 major different implementations. And what's kind of cool about that, and it was great foresight on the part of the Ethereum Foundation and Vitalik, was that in Bitcoin, people are fighting over what the specific Bitcoin code and client is supposed to do. In Ethereum, in a way, you could have different clients implement things in different ways so that there can be a little competition. So they could say, well, we're not going to totally change the protocol, but we're going to do this part a little bit differently. It still fits in the specs of the white paper or the mauve paper or whatever. And we think this way is a little bit better. So it opens it up for a little bit of competition between the clients. Additionally, if there happens to be like a zero-day exploit or a bug or a major flaw that's found in like the C++ client, there's the Go client, or there's another client called Parity, where it can make sure the network keeps running. And there have been at least one instance that comes to mind where if the network was running on a single client, like it could have totally failed, right? Or had a major disaster happen, and a parity client was running great and wasn't exposed to those same issues, or at least not as bad. And so, yeah, survival of the fittest. And then really quick, and then I'll pause for questions in a second, but another major part of Ethereum is something called the Ethereum virtual machine. I mentioned that Ethereum is a Turing-complete blockchain. Really quick show of hands, anyone here ever heard of Alan Turing or Turing machines or anything like that? So about half. Oh yeah, and if you're like a math nerd, maybe more of a math or physics nerd instead of computer science, maybe you've dealt with something called lambda calculus. So you can kind of think about lambda calculus when I'm talking about Turing-complete programs. And so we're going to talk deeper about what that means and how Ethereum is Turing-complete on some following slides. Maybe before I go, though, I'll just ask any questions about kind of these three main areas describing Ethereum. Cool. All right, we're going to dive deeper into those. So let's dive deep into what the Ethereum virtual machine is. It's general purpose, so it supports Bitcoin-like value transactions. So the example we used earlier today was I want to send 10 tokens from account A to account B. That's a very simple value transfer transaction. Ethereum can do those. And it won't make you wait 10 minutes or an hour to do them, so that's kind of cool. Or more complex applications. And when I talk about applications, we could start thinking about that as something called smart contracts. So Ethereum has a couple different programming languages that were created to write a thing called a smart contract. Probably the most popular one is a programming language called Solidity. There's also one called LLL, another one called Serpent, and I think there's even a new one built in Python or Haskell or something, I don't know, called Viper. I don't know a whole lot about those. Solidity is pretty much kind of the de facto standard in Ethereum today. And I'll show you an example of what Solidity's syntax looks like in a few slides. So smart contracts are these like little programs that live inside the blockchain and are copied among the different copies of the ledger, and people come to consensus, or nodes come to consensus by actually not only storing those transactions or scripts, but actually running them when they're mining. So that's kind of interesting. We'll talk more about that. In addition to smart contracts, Ethereum is made up of something called decentralized apps. So the idea is you have smart contracts which hold state. Blockchains are great at holding state. If you think about a blockchain like a database, you have all sorts of state information in that database. You don't necessarily have your user interface, so you don't have HTML or JavaScript. Hopefully you don't have that stuff in your database. Maybe you do. We've all worked on a site or a program like that, right? No judgment. But the point is, ThinkWorld Computer. All right, this is the first decentralized world computer to ever exist, right? So there's decentralized systems and computers like Amazon Web Services. There's cool things in the 80s, 70s, 80s, and 90s where people did distributed computing projects. They all required trust. Because we can have this thing called a blockchain where you can have transactions that don't require trust for the first time in history. Now when we throw in computer programs or scripts into that blockchain, we can do computations without trust. And so we can have no server, no client, just like a distributed network of peers doing things. It's Skynet, man. It's crazy. So, yeah, if that doesn't sink in, sleep on it. That's pretty amazing. All right. I don't know. I'll throw it out there. Any questions? Got one in the back there.
What prevents that from being malicious?
Right, like Skynet. Right? We want to make sure.
Just, there's no authority, so what prevents it from being massive denial of service attack?
Right. Yeah, that's a great question. So something important to remember, and so like a denial of service attack in the traditional sense where you've got botnets just hitting, Amazon.com or, whatever, maybe not Amazon, but whitehouse.gov or whatever. You've got all these kind of robots out there all taking things down, and I know it's immense bandwidth and shutting down ISPs and tier 1 internet providers. Blockchain's a little different in that it doesn't have, the rest of the internet's not within scope of the blockchain. So if you're executing something on an Ethereum virtual machine, like you can't program in an IP address to go talk to you. You can't connect to a server. All you can do is reference data that's within the blockchain itself, plus some other things which we'll talk about later. But essentially, this Ethereum virtual machine can only process its own data. And so if you're running a transaction using the EVM, you're running it on your own computer, on your own set of your own copy of the blockchain. So if you were to try to run those executions in some sort of method to exhaust CPU or memory or other resources, on one hand, you'd just be hurting yourself. But on the other hand, there is a limitation in Ethereum transactions and blocks. It's not block size, but it's something called gas. And we're going to get to that in a couple slides. But gas is this idea, it's like your car, right? So you have to put gas in your car to make it run. You can drive your car maybe 200 miles or 400 miles, and then it runs out of gas. You have to put more gas in. You could think about an Ethereum transaction the same way. So it's a definite termination point where in a block you can only have, I think it's like I'm going to say it wrong, but say it's like 4 million gas or whatever. It's an arbitrary value. You can't have a computation that takes more than that amount of gas. If it does, the EVM refuses to run it, and you lose all the gas you included with your transaction to have it included in the network. And I'm going to talk a little bit more about gas in a few slides, but does that kind of help
Maybe.
answer it?
If it's truly Turing complete, it seems like it should be able to do whatever it could engineer the protocols to get out to reread it.
It can compute anything, it can't do anything.
And you're the computer science professor, right? Yeah, I recognize you. Right. I think by the strictest definition, Ethereum is not 100% Turing complete.
Maybe if you have infinite gas, it would be.
The protocol does not allow infinite gas in a block. And a block can only be composed of transactions that fall under the gas limit. So if you had a single transaction that took, I think it's 4 million, it could be different. Say you had a single transaction that took 4 million gas, you couldn't include any additional transactions in the next block. All right, thanks for going easy on me. All right, so we'll move forward. We'll talk about gas a little bit more later, and we'll also talk about solidity and Turing completeness a little bit more. A small distinction in Ethereum. So we've got two types of accounts, externally owned accounts, and that's an externally owned account is in the sense of like what we were talking about earlier tonight with Bitcoin or in our generic blockchain. It's an account, there's a private key to it, it holds X tokens or X, or Y value, and you can send it to other accounts. But because in Ethereum we've also got smart contracts, there are things called contract accounts. These are accounts that are not controlled by a private key that an individual has on their machine or keychain. It's an account that was created and owned by a smart contract. So if I have a transaction, it contains some code that says, I don't have the syntax right in front of me, but say we create a new account in the Ethereum network, Ethereum will return an account number, and that contract is the sole owner and controller of that account. And depending on how that smart contract was written, the owner of that contract may be able to do things to that account. It could be a group of owners. We'll go into the smart contract example next, and maybe that'll make a little bit more sense. But remember, again, Ethereum has two types of accounts, externally owned accounts and contract accounts. Okay, so this is, I'll preface this as this is pseudocode. This is not an actual syntax. But again, it's important to understand, excuse me, an Ethereum transaction can include more than just value transfers. It can actually have logic or scripting. And so just really quick example here. In this case, we have contract C sending, in this case, something of value, a dividend to account A. In our earlier example, it was just a simple, straightforward transaction from A to B. In this case, we want some conditional logic, and we want to do some computations before we send that value. We need to check some things. So in this case, this is an example where we're going to, we've got a smart contract. It's got a collection of accounts in it that says these accounts are owners of the smart contract. This smart contract could represent ownership in a company, for example. And so we want to allow members of that company to be able to take dividends out every fourth quarter at the end of the year. And so we check if account A were to make a call to the smart contract and say, hey, I want my dividend, I want my money. The first thing the contract's going to do is it's going to check, is this account that's calling me, are they a member? And is it fourth quarter? If the account's not a member of the organization, if it's third quarter and they're trying to call it early, it'll fail. It won't do anything. But if those conditions pass, all right, let's calculate the dividend. Let's look at what's the value of everything in the smart contract. The smart contract, again, can own its own account. It can contain value itself. It's going to say, all right, I'm going to take 25% of my current value, and I'm going to issue a transaction from myself to the account A, which is calling the contract, and issue the dividend. So very crude, simple example. More complex than just saying send 10 tokens from A to B. We're actually going to do some conditional logic. We're going to do some computation. And if you're to look at Solidity or the EVM opcodes or instruction set, you'd see there's a whole bunch of different instructions you can do in one of these transactions. And you don't have to worry about writing opcodes or machine code for the EVM. You can write it in kind of user or developer-friendly syntax in Solidity or Serpent or Triple L. Really quick note on this contract. There's a big bug in it. We don't check to see if they already called it, right? So they're probably going to drain those dividends really quick. So, it's kind of a crude example, but does that make sense? Are there any questions about it? All right. All right, let's talk about gas.
Does the, so like the program, when you're saying you can submit a program, does that program then live in the blockchain, and then like some future person can go make another transaction that references the existing program?
Yeah, great question. Yeah, so when I want to issue that transaction, again, I need to broadcast that transaction to the network of peers out there. In this case, I want to send it to the Ethereum network, so I'd use an Ethereum wallet that's capable of sending and broadcasting transactions. And in that transaction, if I'm making a simple call to an existing contract that lives out there in the blockchain, then I know the address on the blockchain and I know how to call it and interact with it. If it doesn't exist on the blockchain yet, I need to actually deploy it to the blockchain. So I would take that, in this case, like Solidity code, I would compile it to something that the Ethereum virtual machine can read. I would include that as a big blob in my transaction to the network, essentially deploying that contract on the Ethereum blockchain. So once it's on the blockchain, if it's written to be reusable, in this case, I want it living out there so that it can collect money and members can collect dividends, then those members need to know the address of that smart contract in the blockchain, and they would create a transaction that calls to that existing contract address. Great question, thank you. Yeah?
What if you put code that does have a bug in it into the blockchain and then want to fix it? Is there a way to?
Yes, you have to redeploy it. Right, so the nature of blockchain is once it's on there, it shouldn't be able to be changed. And so that's where there's interesting new design patterns, maybe not totally new, but there's interesting design patterns and consequences to how do you create smart contracts. So if, yeah, I mean, like if you create a site today, it's got a domain name or an IP address, you throw your code there. Here, I'll try to shadow there. Yeah, so in traditional like internet sense, I could just re-FTP or update the Git repo or whatever, redeploy on top of that, so that when you go to that domain name, it goes to the correct code. In the case of Ethereum, we would have to redeploy either that whole contract or create a design pattern where instead of using one monolithic contract, perhaps we have a little bit more of a hierarchy to our smart contracts, so that maybe when I call into the smart contract, it checks to see what's the most recent other smart contract on the blockchain. So yeah, it gets kind of detailed, interesting design patterns, and they still need to be figured out. Thanks. Any other questions?
Yeah. You can pass on this one if it doesn't apply in this situation, but is this really general purpose? Like, could one of these smart contracts be something serving up some code to pull something from a database and serve it to a web page?
Yeah, great question. So yes and no. It couldn't pull anything from a database, say a particular IP address or domain name. It could pull stuff from a database that's on the Ethereum blockchain, right? So there could be some other smart contract with data in it. There's something called IPFS, which is a distributed storage, distributed file system. Stands for interplanetary file system. So it's essentially, think about it like BitTorrent, right? So you've got little pieces of a file that live out there on different computers. You just request, you have like some sort of unique identifier for that file. You request that file, and the network figures out where to pull it from. There's a slide here where we're going to talk about dApps, where essentially you've got state data or your database, which is the blockchain, and then you have maybe other resources like, in my example, it's user interface files, so it could be HTML files or JavaScript files, things that you wouldn't want to store. It would be expensive to store on the blockchain, but you want to pull those resources in. And so Ethereum itself doesn't necessarily know how to access those, but using browsers that understand how to access the Ethereum blockchain and access those distributed storage solutions, there's like a browser called Mist. There's another one called Signal, and there's another one that was just announced by Coinbase last week called Token. But the idea is you can access your decentralized database, which is the blockchain, and decentralized files, and combine them together into something called a dApp, or decentralized app. And we're going to talk a little bit about some examples of those a little bit later. So I mentioned gas earlier. This is a crude representation, but what I was trying to show is that, so if we just kind of go line by line here, we have some different computation operations, right? So we've got an if statement, we've got an and operation, we're checking to see if something's equal, we've got a division operation. So we've got these different computations in this smart contract. And so again, this isn't totally one-to-one, but I was trying to show that each of these instructions, if, and, equal, divide, they have different costs associated with them. Those operations or opcodes and their associated costs are built into the protocol. So when you're mining Ethereum blocks, you're processing transactions, you're processing the code in those transactions, and every instruction you run includes gas, and you would collect those gas fees when you create the next block. And so like a simple comparison operation is very easy. For a modern day CPU, it doesn't take a whole lot of computing power. If you're doing like some sort of basic add or subtraction, maybe that's a little bit more complex. If you're doing some sort of like floating point math or calculations, it'd be more complex, it'd take more computing power. And so the idea is Ethereum wants to charge more gas for more complex operations. Now, of course, not all hardware is the same, not all CPUs are the same, not all memory or systems are the same. So it's an estimation. And one thing that was found about 7 months ago was that some of the Ethereum opcodes were underpriced, and there was an attack on the network, essentially spamming the network with transactions with these kind of underpriced transactions to where it was really clogging up the network. And so there were some updates released to try to kind of estimate those costs better. But again, gas is different from Ether. You use actual Ether to pay for gas, but it's like gas in your car in that there's an exchange rate, right? So gas could cost $2 today or $4 tomorrow. It's the same with Ether and gas. The idea is you want to price the transactions a way that makes sense. The value of Ether changes from moment to moment, hour to hour, day to day. So for example, like in 2015, Ethereum was worth like $1 US, an Ether, and today it's sitting at like $50, right? So if you had a smart contract that was really complex and it cost you maybe $1 to run it 3 years ago, we wouldn't want it to cost $50 to run it today. So you need some sort of ratio or gas computation to try to adjust that cost so that it's not unreasonable based off of the exchange rate of Ethereum and the US dollar or euro or whatever. Does that make sense? It's not too complex, but maybe I explained it poorly too. All right, let's move on. So really quick, we'll kind of roll through this. So we went through a generic blockchain, and we talked about, all right, this is a transaction. We just went through an Ethereum transaction, a little bit more complex than just sending 10 tokens. It was doing some logic and then issuing an exchange between contract C and account A. So in this case, if we're a miner, we're taking those Ethereum transactions, we're putting them into a block, just like we talked about before, and then we're appending that block to the previous block. Yeah, so really quick aside here, if that didn't make sense to you, sometimes I pronounce, like, there's a lot of fintech people, so people coming more from like the finance side of things. If you think about it like a spreadsheet and you've used Excel a lot, again, you could think about each row being a transaction number, and our x-axis or columns are different accounts. And so we're kind of showing the totals with each account here. And so we could have a simple transaction where we move 5 units from account B to contract C. Or we could have a more complex like macro where we're referencing other cells and doing computations before we return the result in that cell. So sometimes the slide confuses people. Other times it makes it really sink in that instead of just typing a number in this box and doing a simple value addition or subtraction, we can actually have some logic. We could have a macro, or we could reference other cells or make calls to our database or our blockchain to then come up with a result. And so that's really kind of the difference between Bitcoin's just moving those numbers around. Ethereum would be like running a macro in a spreadsheet. Does that just confuse it more, or does that help? Yeah.
I think one real world use case above the dividend without that's better.
Yeah, I've got about 8 of those. So great. Yeah, perfect. All right, we'll try to get there quickly. So we're not going to go through this. This is just a very quick example for those of you that are syntax nerds. This is what Solidity looks like. I think it might loosely be based off of something like, I didn't want to say, like, it might be kind of based off Python syntax, but I don't know if the indentation matters. So I don't know. I mean, if you've coded, you probably get the idea of what this means. This is just from Ethereum.org, like one of the first example programs. So we're not going to go through what this means. This is some sample code, though, for creating your own token on Ethereum. So if you wanted to create, like, you could create a token called Bitcoin that runs just on Ethereum, and people could trade it around. Like, so I don't know. There may be ways for Ethereum to do what Bitcoin does, but that's probably more just an exercise. not reality. So getting to examples, I talked a little bit earlier about dApps or decentralized apps, and I kind of broke it off. It's these two areas of smart contracts, which are stored in the blockchain. So we've got this ledger, we've got this blockchain. It's copied to computers and miners and peers around the world. We don't want to cram a bunch of like binary data or JPEGs or HTML or JavaScript onto the blockchain. So we need another place to store those. And in the case of Ethereum, people that are building dApps today are using a solution called IPFS, which I talked about earlier. The Ethereum protocol itself is building a decentralized file storage solution called Swarm, which will be built into Ethereum, and then you could essentially reference Swarm objects from within the Ethereum blockchain. So it kind of creates an all-in-one solution for taking an application, putting it out to the world, and let it just existing in a decentralized manner. And we'll go into a couple of examples if that doesn't make sense. So I could really get bogged down in a lot of these examples. I'm going to kind of fly through the next 2 slides to give you an idea of some of the use cases for dApps and smart contracts. And then I'm going to kind of not dive too deep, but go into 3 specific examples from this list. So I got kind of derailed last time I gave this presentation on this slide, and we're here for, it felt like an hour. So I'll spare you that, give you a taste. So decentralized exchanges. So today, if you've got Bitcoin, you can convert that Bitcoin to Ethereum. And I think 1 Ether is worth like 0.04 Bitcoin, for example. And so if you want to exchange that, you need to trust a third party that you send your Bitcoin to, and then they send you back Ether. So it kind of, it's very helpful, and banks and trusted third parties I don't think need or will go anywhere. They're going to be around for a long time to come. But when we're working with decentralized technology that is built on the idea of not trusting other peers, wouldn't it be cool if we could exchange value between different blockchains and cryptocurrencies without trust? And so there's these things called the centralized exchanges. A project, if you want to write these down or look them up if you're interested in this area, there's one called EtherDelta, another one called Oasis that are doing that. There are a couple projects in the world of prediction markets. So prediction markets, some people call it wisdom of the crowds. Other people call it gambling. An example of a prediction market would be who's the next US president going to be, and placing a bet on that. The idea being, if I'm placing a bet where I'm putting my money on it, I'm likely going to tell you who I really think is going to win and what the correct answer is, as opposed to just telling you what I think I want you to hear. Another example would be who's going to win the ball game tonight, right? And putting money on that, so betting or gambling. Prediction markets are really interesting. So Gnosis did a crowd sale yesterday, and they raised $12.5 million in 10 minutes, all on Ether. They raised like 1.5 million Ether in literally 10 minutes, and I think maybe 19 seconds or something like that. No venture capital, people to deal with, no investors. They created a program, threw it out onto the blockchain, and raised $12.5 million worth of Ether in 10 minutes. Holy shit. I mean, if Ethereum didn't do anything else right, that's a pretty killer app, I would say. So there's all sorts of potential drawbacks and regulatory issues and all sorts of other things that may not be good, right? And these are things that need to be figured out, certainly. Distributed computing is a very cool project called Golem that's aiming to create a client so you could run it on any spare computers you have, spare mobile devices, where you could essentially lease out that computing power to the global computing machine. think about it like Amazon Web Services except decentralized. So you've got spare computing capacity, you run an app, it sits there, it provides computation power to people. You don't have to worry about PayPal or credit cards or banks or trusted third parties. It's built into the protocol that you receive cryptocurrency in return for leasing out your computing power. If any of you are fans of Silicon Valley on HBO, season 4 premiered on Sunday night, and like the whole essence of this season is about creating a decentralized internet and taking advantage of like cell phones in your pocket. So like basically, Mike Judge and all the writers at Silicon Valley are watching Ethereum and Golem really closely, so I'm like excited to watch this season. We also had one of the founders of Golem present at our last meetup. I run the Michigan Ethereum meetup group, and Alex Leverington presented Golem to our group at Ann Arbor, and he was one of the original developers of the C++ client at the Ethereum Foundation 2 or 3 years ago. So really cool guy to have at our meetup, and an awesome guy to be driving a project like that. Identity management, so tracking passwords, private keys, all that stuff. It gets really funky when you've got like 10 Bitcoin sitting in some wallet somewhere on your computer, and some Eastern European hacker owns your Windows box and takes all your money. It almost happened to me. We need interesting ways to not only manage private keys, but in identity, but how do we actually interact with these different dApps and prove we are who we say we are, and transact across different dApps and accounts and private keys, and how do you manage all that? Uport's a very interesting project, coming up with a way to manage that. It's also, it should be mentioned that what's cool about dApps is as more dApps are created and launched on the network, it's not like a linear growth thing. Like dApps can build upon each other. So you may not have the time to build an identity management solution in your prediction market. You just plug in Uport, which is at this address in the blockchain. And so now, the same way that content management systems and open source code changed websites in the internet, now you've got that with finance and money and decentralized computing. So it's really interesting how there can be almost like an exponential curve to the value of the Ethereum blockchain as more people and developers build on it. See, I'm spending a lot of time in this slide. I apologize. So to get through this really quick, we talked about crowd sales, digital asset management. There's a cool startup called Digix. We're going to talk about that in a second. Internet of Things, so you've got blockchains and clients that access the Ethereum network. Why couldn't it live on your cell phone, or the lock that, the electronic lock that powers that door? Why couldn't that interact with the blockchain? And Uport that says, runs on your cell phone, so you walk up to a door or an Airbnb and you pay the lock, or the lock in the self-driving Tesla that's down the street, a year from now. What if I just pay the card directly to take me from here, downtown? That could all be powered by Ethereum. Digital governance, energy management. We don't even have time to get into all that. So let me go through a couple examples, and then I'll pause for questions. I'm getting close to the end of the presentation here, and I know I've said a lot. So let me roll through a couple of these, and then we'll pause for questions. All right, so Augur. I already kind of dove into prediction markets. Augur is a specific one. They had a crowd sale about 1.5 years ago. I think they raised a little over $4 million. They do have a beta version of Augur deployed and working on the Ethereum testnet. It's getting really close. They could be released to production this year. Go to augur.net if you want to check that out. Digix, so I talked about digital asset management. Digix is a startup in Singapore. They're figuring out a way to track physical assets like gold bars or one little gram blocks of gold on the blockchain. So their idea is you have a physical asset and a cryptographic token, and you've got physical images and documents underwritten by like Lloyd's of London, the people that insured the Titanic, saying that there's a valid piece of gold sitting in a vault in Singapore that's tied to this digital token. And now instead of having to pick up that gold, ship it, insure it, protect it, to send it from point A to B. I can just send a token in a matter of about 15 seconds over Ethereum. Like that gets really interesting for tracking physical assets in the real world. EtherDelta is an example of a decentralized exchange. Yeah, I won't go too much into this. I talked about this already, but the idea that there's Litecoin, Bitcoin, Ethereum, there's 1,000 different tokens out there. What if I want to convert between those two in exchange with other market makers and takers? EtherDelta is working, creating a decentralized smart contract, dApp, which would allow us to do that with each other. And so to wrap up the next few slides, I'm just going to talk about some future features coming with Ethereum. Ethereum, in essence, is still in beta. It's in something called the homestead phase. Frontier was kind of original launch phase. There's another phase called Metropolis, which could hit this summer. The idea being these are kind of like versions and groups of features. And so every time Ethereum comes out with like the next version, so this case Metropolis, it'll do something called forking. And so you mentioned the word forking earlier when I was talking about chain reorganizations. Fork, in maybe the broader sense, talks about like a fork in the protocol. So we all agree at this point in time, we're going to change the protocol to do things a little bit differently. And that can create issues if you don't do it right, because you could have old clients running the old version of the protocol that now are adding blocks with different rules than the newer clients. So the way you go about doing hard forks and upgrading the protocol, you have to have some foresight into how you're going to do that down the line to make sure you don't code yourself into a corner. And sometimes there could be forks that are not ideal, or there could be people that take an old version, keep running with it anyway. And so that happened with Ethereum about a year ago. So there's something called Ethereum Classic out there, which is different from Ethereum. And I mean, it's another token out there. If you go to buy Ethereum, though, don't get confused. Ethereum Classic or ETC is different than Ether. Whether, no matter where you fall on the political landscape of liking hard forks, or whether you like ETC or Ethereum, the point is just be sure you understand what you're buying if you do buy some. Ethereum likes hard forks. It's already forked 4 or 5 times. A lot of people don't know that, and that's like forks are fine in Ethereum land. Okay, a few more slides. These are some features coming down the pipe. So Casper is a proof of stake protocol that will remove the need for mining. So today, I think there's more computing power mining for Bitcoin than all of like Google's computing power added up, right? Now, I don't have a source for that. I've heard that. I think there's some studies out there that show how much computing power is being used in Bitcoin. It is a tremendous amount of electricity and resources being spent. Like people are burning coal to create Bitcoins, right? It's kind of silly when you think about it. So proof of stake is actually a way where you won't need mining anymore. I guess the details about proof of stake are beyond the time we have for this presentation, but if you're interested in consensus protocols, I would definitely recommend checking out Casper. We talked a little bit about decentralized and distributed file storage. Swarm is a feature being added to Ethereum. The alpha version of Swarm is out there. It was released in December of last year. I think they're getting closer to a beta, so it exists, and there are people kind of playing with it and testing it. Whisper. So Whisper messaging is really interesting. So just the idea of having secure end-to-end communications that like the NSA can't crack, like that's pretty revolutionary in itself. So yeah, it'd be kind of cool if we had chat programs that were secure. But let's go a little deeper than that. What if we've got smart contracts that need to be able to communicate, and they can't wait 15 seconds or 20 seconds for the next block? They need to communicate quicker in real time. Whisper is a kind of off-chain protocol to facilitate that secure end-to-end communication between accounts. And remember, accounts in Ethereum could be externally owned accounts, so between the actual people, or contract-owned accounts, which are between contracts. So Whisper exists in, I don't know if it's alpha or beta phase. It's out there. There are some tools using it. I'm playing around with it. It's not production ready or finalized yet, but I mean, that's awesome. Raiden, state channels. So one of the concerns about Ethereum and a single blockchain is how does it scale? And we didn't talk about scaling at all tonight. You know, if you're just handling payment transactions like Visa or MasterCard, you know, you need to be able to handle probably, I don't know, 4,000 or 10,000 transactions a second. You know, I think Bitcoin can handle like 4 transactions a second, and Ethereum's probably at like, I don't know, 20 or something. Those numbers aren't totally correct, but it's a factor of magnitude below what like credit card companies can handle. Yeah.
So would that let me like create a day's worth of my own transactions and then post them?
Yeah, exactly right. So state channels, the idea is we as parties may agree, all right, we're going to have a lot of transactions maybe during the day, during the hour, during the next 5 minutes. We don't need them all to be public. We just need to be able to know at the end of the day, if we've sent money back and forth to each other, at the end of the day, how much do you have and how much do I have? So we have a point where we reconcile on-chain. And so Raiden's a really cool state channel solution that, in Bitcoin it's called payment channels because you're just transacting value. In Ethereum, not only do you have value transactions, but again, you've got like programs with state running. So Raiden's a little bit more complex than like Bitcoin's Lightning Network. And then I just added this one today, ZK Snarks, anonymous transactions. Bitcoin's not anonymous, it's pseudo-anonymous, Ethereum's not anonymous. If you figure out who the account holder is, you can kind of trace the transaction history because it's public. So ZK Snarks are an interesting way to anonymize transactions. Sharding, think about having like, instead of one Ethereum blockchain, we had 10, and then those 10 kind of interact with each other. So instead of having the whole blockchain, I only have 1/10 of it or 100th of it. Sharding, just like with databases or other methods of computation, there are ways being worked on to shard the Ethereum blockchain. And with that, I am done. Thank you very much for listening to me tonight. I know I went through a lot. Again, I'm Alex Fisher, and I'm looking for people interested in working together, people that are interested in consulting, anyone that wants to nerd out or just talk blockchain or Ethereum. It'd be fun. So connect with me on Twitter, Keybase. I run the Michigan Ethereum Meetup group. Join that. The Ethereum subreddit. It's great. Twitter, everywhere. So thank you very much.